Hello fellow explorers, this is Tony Toppy and today I will be talking about the sun. For starters, let's go ahead and begin with the size of our sun. When you're looking at our solar system, the sun is gigantic. In fact, the mass of the sun accounts for 99.86% of the total mass in our solar system and is about 864,000 miles in diameter. But when you take our sun and compare it to other stars, our sun actually ranks as a pretty average-sized star. There are lots of other stars that are smaller than the sun, like the one shown here and here. You can also find stars that are 100 times bigger in diameter than our sun, like the one shown here on your screen. So, for comparison's sake, Sirius is about 1 million miles in diameter, whereas the giant Betelgeuse star is 1.021 billion miles in diameter. And to the very last point of this slide, what type of star is our sun, you might ask? Well, our sun is considered a G-type main sequence star, or GV for short. Now we're going to talk about the location of the sun. While I'm talking, I just pressed play for this video here on my right, which is going to pan out to give you an idea of where we're at on the Milky Way itself. So the sun in our solar system is located within the Milky Way galaxy. The sun is in the spiral arm of the Milky Way called the Orion Spur. It is right here that the sun orbits the center of the Milky Way galaxy, bringing along our entire solar system with it at the average velocity of 450,000 miles per hour. At this speed, it takes us approximately 230 million years to make one complete orbit around the Milky Way. Next, let's talk about the structure of the sun. The sun, like other stars, is a ball of gas. In terms of mass, the sun is about 70.6% hydrogen and 27.4% helium. This image shows us that the sun has 6 different regions. We have the core, the radiative zone, the convective zone, the photosphere, the chromosphere, and last but not least, the corona. So how does the sun create energy? Well, to explain this process, I'm going to go ahead and press play for the sun crash course video, which will shed light on how this happens.
Ionized, which means the electrons in the atoms are stripped from their protons. This makes the core a thick soup of ultra-hot subatomic particles. In fact, the protons are squeezed together so hard by the octillions of tons of mass lying on top of them that an amazing thing happens. They fuse together. Through a complicated series of steps, the hydrogen atoms fuse together to form the heavier element helium. Along the way, some of the nuclear energy stored in those atoms is released. That amount of energy is described by Einstein's famous equation E=mc², which states that mass can be converted into energy and vice versa. Atoms are pretty small though, so each helium atom made in the sun's core generates only a tiny bit of energy, but a lot of helium atoms are made. A lot. Get this, every second of every day, the sun converts 700 million tons of hydrogen into 695 million tons of helium.
So, to summarize this video, there's a whole lot of pressure happening within the sun's core. Now, this is where the hydrogen is fused together to form helium, which ultimately creates energy through the nuclear fusion process. And then this energy then flows out through the core via radiation. So with everything that I've learned about the sun and learning about how truly majestic it is, I personally can't even begin to think about the fact, like all stars, that the sun is going to someday run out of energy. As a matter of fact, scientists predict that the sun is a little less than halfway through its lifetime and will last another 6.5 billion years till it shrinks down to become the size of a white dwarf. Just for size comparison, here's an image of the Earth showing its relative size to the white dwarf star. Thank you for watching.